Greetings fellow geeks and welcome to another Geek Moment video. My name's Chris Baird and today we're going to be looking at the VLED15 LED driver from CUI, but first a little history. For the last 100 years this has been the primary source of light in our homes and businesses, but due to new onerous government restrictions these are being slowly phased out. This is opening up new opportunities for other sources of light such as the CFLs we're getting used to, but also high brightness white LEDs are coming into play and we're going to look at some of those solutions now. LEDs are fairly particular on how they're driven. They require a relatively low voltage, constant current DC, but unfortunately what's available is a high voltage AC. Another consideration to keep in mind is the millions of triac dimmers installed around the world to dim incandescent bulbs. That's something we need to consider when we're looking at constant current LED drivers. Here we happen to have just such a triac dimmer, and to take a look at its operation we've got it connected to our incandescent light bulb. The switch is a little nuanced in that it has to get fairly high before it starts conducting. This is the minimum conduction angle for this light bulb to turn on. From here we can go all the way up to full brightness and back down to 0. And 0 is about horizontal on this switch, so we'll just keep that in mind when we take a look at our LED driver. So here's why we need to keep triac dimming in mind when we're going to design or choose an LED driver. We've got a driver here that was not designed for triac dimming, and here's what happens when you connect it to a triac dimmer. Obviously the results are less than desirable, and we're going to take a look at one next that is designed for triac dimming.
Unless you own a disco club.
Unless you own a disco club. Here we've got another LED driver that is designed for triac dimming. We're going to bring it up now, and you can see that there is still some flicker in this driver. Triacs need a minimum amount of load to operate consistently, and this driver by itself is not providing enough of a load for this triac to operate consistently. Now we've got our VLED15 LED driver connected. This is hooked up to 2 LEDs in series because of the output voltage requirements of this particular driver. We're going to take a look at the dimming range now on our triac dimmer. The VLED15 LED driver has some advanced filtering built into it, and even though it's the only load right now on the triac, they've done a good job of filtering out the flickering artifacts from the light as we go through the triac range. Alright, we've got our VLED15 LED driver set up, we've got our trusty old incandescent bulb set up, and we've got our other triac dimmable LED driver hooked up as well. These are all connected to the same triac, and as you watch the switch as I come up, they all turn on in about the same position on the switch. And from here we can come up to full brightness. Take a look now. We've got 60 watts being consumed by our incandescent bulb. These 2 LEDs combined are drawing about 12.5 watts, and these 3 are consuming just short of 19 watts. And you can see the brightness comparison. Obviously LEDs give you a lot more lumens per watt. Also notice as we come down through the dimming range that you don't see any flicker from any of the light sources anymore. This is because the triac is properly loaded, and even the driver without the filtering is doing okay with flicker right now. We want to thank you for tuning in for another Geek Moment. We look forward to seeing you again next time. Hello Geekvillians, this is the mayor of Geekville.
Yeah.
Did that get recorded?